Okay, this video is for the 7.2 lesson, the converse of the Pythagorean theorem. And our objective is we're going to classify the triangle by angles given only side lengths. So we are going to be looking at three theorems here, but all three of them will share this in common. The triangle is going to have capital letters as the three angles and lowercase corresponding letters as the opposite sides. So opposite angle capital A is side length lowercase a, opposite angle capital B, side length lowercase c, and opposite angle capital C is lowercase c. And for all of the theorems, our lowercase c is going to be the longest side, and our capital C is going to be the largest angle. It's very important that we use our longest side as the C values. The A and the B values can be swapped, and that won't be any problem, but we have to set it up so that C is the longest side and capital C is the largest angle. And technically, of these three theorems, only this first one is called the Pythagorean Converse, and these next two theorems are very closely related. If c squared, if the hypotenuse squared equals a squared plus b squared, then the measure of angle C, the largest angle, is 90 degrees. But it actually also works for acute and obtuse triangles too, sort of, in that if we don't have an equal sign there, perhaps we leave it as a question mark. Once we square the two shorter sides and add them and square the longest side, whatever goes there in terms of a less than or greater than, then the angle C, the largest angle, will have that exact same relationship with 90 degrees. Which is why when we were doing the Pythagorean theorem, I suggested putting C on the left side. It just sort of prepares us for these three theorems. And so if the longest side squared is less than the sum of the other two sides squared, then measure of angle C is less than 90 degrees. The triangle will be acute. If the longest side squared is greater than the sum of the squares of the other two sides, then the measure of angle C is greater than 90 degrees, and the triangle will be obtuse. Okay, as you remember from a previous lesson, at most, any triangle would only have one angle that is greater than or equal to 90 degrees. Because the three angles have to add up to 180, you could never have two angles that are more than 90 apiece, or even two angles that are equal to 90. So in every single triangle, every triangle has at least two acute angles. So when we're classifying a triangle by angles, we're really only looking at the largest angle. So if we can figure out the largest angle's relationship to 90 degrees, then we can classify any triangle as acute, right, or obtuse, given the three sides. Okay, so I have some examples in this video lesson for the first set of sides. What we're going to do is we're going to take the longest side and square it, and then we're going to compare that to the sum of the squares of the two shorter sides. We'll use our calculator here. So 15 squared, we'll get that, and then 9 squared plus 12 squared, we'll get that. Now, because we see, sorry about the glare, that's a little better. We see here we actually get the same value. 15 squared is 225. 9 squared plus 12 squared is 225. So it turns out that there's an equal sign there. That means the measure of angle C is equal to 90 degrees, and this triangle is a right triangle. Okay, let's take a look here. The longest side is 26, so we're going to compare 26 squared to 14 squared plus 22 squared and see what we get there. So 26 squared, 14 squared plus 22 squared. Oh, okay. So this time, the longest side squared is 676, and the sum of the squares of the other two sides is 680. So we get c squared is less than the sum of the squares of the other sides. That means the measure of angle C is less than 90 degrees, and this triangle is acute. Okay? I'm going to talk more about this in a second, but if you're not sure how long a radical side length is, you can just enter it into your calculator to get the decimal approximate. 8 root 2 is approximately 11.3. So 8 root 2 is the longest side here. So that's our C value. So we'll square that and compare that to 10 squared plus 5 squared. So here we have 64 times 2, which is 128. 100 plus 25. And in this case, the c squared is greater than a squared plus b squared. That means the measure of angle C is greater than 90 degrees, and this triangle is obtuse. Okay, now we're going to see this question phrase, if possible, coming up real soon on any assessments. So the whole if possible business comes in when, remember from before when we looked at the triangle inequalities, the longest side of a triangle must be less than the sum of the other two sides. Otherwise, it's not even a triangle. If you had some side 15 and some side 3 and 4, the 3 and 4 don't reach across 15. It's not even a real triangle. Quick little sketch here. If I had a side 3 there and a side 4 over there and a side 15 here, it doesn't even form a triangle because those two little sides are short. Too short. And then I just mentioned this a moment ago. If you have some radicals and you're not sure, maybe you should enter it into your calculator real quick. So I don't know. I don't remember how long 3 root 34 is. So I'll just enter that in my calculator real quick. Okay, so that's 17. Okay, that's good news. This is a triangle because 9 plus 15 is 24. That's bigger than 17.5-ish. So it's definitely a triangle. And I know that 3 root 34 is the longest side. So I've determined which is the longest side. It's time to now square the longest side and compare that to the sum of the squares of the other two sides. Now, when entering this into your calculator, either use our trick discussed before. This is going to be 9 times 34. Or please use parentheses. I'm going to show you real quick here. The parentheses totally matter. If you don't put the parentheses in, you get the wrong answer. So 9 times 34 also gets you that 306. But let's say I just didn't put parentheses and I just did 3 root 34 squared. We get the wrong answer here. The reason is that calculators don't recognize order of operations if you type things in a little sloppy. What the calculator is doing in both of these cases, whether it was in the square root or out, I kind of want to put it out just to show you that just scrolling out of the square root, that's not good enough. What the calculator does here is it thinks that only root 34 is being squared. 102 is 3 times 34, but it's 3 root 34 times another 3 root 34, which you can get by using the parentheses or the shortcut of just squaring the number outside the radical and then multiplying that by the number inside the radical. 9 times 34 is 306. Anyways, let's get back to this problem here. So we got 306. What is 9 squared plus 15 squared? And as you can see here, it doesn't matter what the order is of A and B. It doesn't even matter what you call A and B. Oh, look at that. That's equal. So this is a right triangle because the measure of angle C, the largest angle, equals 90 degrees. Okay, let's see what's going on here. Let's get decimal approximates for 3 root 3, 5 root 2, 7 root 6. Uh-oh, we got a problem here. 17.146, yada, yada, yada. That's too long. 5 and 7 won't reach. It's similar to this scenario here, where the long side is too long. So this one is not even possible. It's not even a triangle. So be careful and make sure that you double check to see if it's even possibly a triangle. And then if it is a triangle, make sure you have the longest side as the C value. And as long as you put the C on the left, we'll leave the, don't fill in the equal sign or the less than or greater than until you actually crunch the numbers and see, well, what is it? Is it an equal sign? Is it a less than? Is it a greater than? And if you put the C squared on the left, then whatever that inequality or equal sign is, that's exactly the relationship angle C has with 90 degrees. So less than, greater than, equal to. And that is how we classify triangles by angles given only side lengths.